This is from the 2025 FRQ section. This year they had two Taylor polynomials, so they had them on 5 and 6. So this is question 5. They gave us a differential equation, an initial condition. They want us to find the value of the second derivative at the point x equals 1, y equals negative 1. Part B says, write the second degree Taylor polynomial for f about x equals 1. Part C, the second degree Taylor polynomial for f about x equals 1 is used to approximate f of 1.1. Given that the third derivative is less than or equal to 0 for all x in the interval, use the Lagrange error bound to show the approximation differs from at most 0.01. So if we're going to do the second derivative, we have the first derivative, and notice that it's a product rule, and it's going to be implicit differentiation because we do not have y solved for. So when we find the second derivative, that's product rule derivative, the first one, copy down the second one, plus copy down the first one, derivative of the second one. So 2y times y prime. Now they want us to find the value of this at 1, negative 1. But notice I need to know the value of y prime. So I'm going to go ahead and evaluate that first. So dy dx at that point 1, negative 1 is equal to 3 minus 1 times negative 1 squared, or 2. So now going back to find the second derivative, this will be negative 1 times y squared, 3 minus x times 2 times y prime, which is 2. And we go through and evaluate that. So negative 1 plus 2 times negative 1 times 2, so plus a negative 8. So my second derivative is negative 9. So remember what a second degree Taylor polynomial is. And again, we're going about x equals 1. So our P2 Taylor polynomial would look like f of 1, f prime at 1, x minus where it's centered, the second derivative at 1, x minus 1 squared over 2 factorial. And now we just have to look for our information. They told us f of 1 is negative 1. F prime of 1 we found in part 1 is 2. Our second derivative we found in part A is negative 9. So this is our second degree Taylor polynomial. Okay, so we have our second degree Taylor polynomial, and it's used to approximate 1.1. So since this was a second degree Taylor polynomial, we know the error will be with the third term. And it's not really the third term, it's maximizing. So maximizing the third term. All right, so the third term of a Taylor polynomial would look like the third derivative at x, and here we'd really have x minus c to the third over 3 factorial. We know that we were centered at 1. And this x right here is where we evaluated. So our evaluation is going to be at 1.1. So this isn't what I'm going to write on my Lagrange error. This is just kind of work that I'm going to do before I start it. So this would be 1.1 minus 1 cubed over 3 factorial. So what I would really write is we want the Lagrange error maximizes the first omitted term. So we know that our error is going to be less than the maximum. And you can put your absolute value. You're going to have the third derivative, 0.1 cubed over 3 factorial. Now, we're going to maximize this, and it's important to put where we're going to maximize it over. You always put from where it's centered to where it's evaluated. So this is your centered, and this is where you're evaluating. Now, they gave us some information. They told us that our second derivative is less than or equal to 60. So this would be 60 divided by 3 factorial, which is 6. And instead of 0.1, I'm going to write it as 1/10. So this would be 1 over 10 cubed. So if we simplify this right here is going to become 10. So this is equal to 1 over 10 squared. And that's exactly what they wanted you to say, is that it was less than that. So our error is going to be less than this value. D is Euler's equation. So remember, Euler's is y1 is equal to y0 plus h f prime x0 y0. So you're having an initial condition where you're starting, then you're following the slope field for some distance h. So they wanted us to do 2 equal step sizes, so we set up our little chart. The first line is our initial condition. They want us to approximate f of 1.4. So this is the answer we really want. They are equal step sizes, so this would be 1.2 in between them. Remember, h is what you add to get to the next term. And now we have to calculate. So to get to y2, I first have to calculate y1. So y1 is equal to y0 plus h of f prime at that point. So y0 is -1, h is 0.2. And we already calculated our first derivative in the first part of the problem, and I believe that was 2. So our next point is 0.6, negative. And now we have to do this again. But now we're going to use these values. So we're going to calculate y2, which is going to be y1 plus h, f prime of x1, y1. So y1 is -0.6, h was 0.2. Now I have to plug these values into my differential equation. Here's my differential equation. So this would be 3 minus 1.2 and then -0.6 squared. And you're going to leave your answer like that. But make sure you tell them this is what you were trying to find. So f of 1.4 is approximately equal to that. Now they will not take off a point if you didn't write approximation, but you need to tell them that you found what you were supposed to be finding instead of just leaving it floating. All right, so how was this one scored? Part A is worth 3 points. Your first point was using the product rule. The second point is using the chain rule. Your third point is evaluating it. Part B is 2 points. 1 for the first 2 terms being correct, 1 for the third term being correct. Part C is worth 2 points. 1 for having the general form of the Taylor-Polynomial, or Lagrange error, and 1 for plugging in the values. And D is worth 2 points. 1 for the first step of Euler, and 1 for the second step of Euler.